Okay, we're moving on to galaxies in the universe, part 2. There really aren't that many notes for this one. Okay, there are 3 types of galaxies. Hold on, sorry. Okay, sorry about that. Okay, there are spiral galaxies, elliptical galaxies, and irregular galaxies. Honestly, they're named for the way they're shaped. A spiral galaxy is like our Milky Way. It literally looks like a spiral. An elliptical galaxy is, sorry about that too, is disc shaped or like an ellipse. Kind of think of like football in shape. And then an irregular galaxy has no distinct shape whatsoever. Most galaxies are located in groups rather than being spread throughout the universe. So think of them kind of clumped together with a lot of space in between. And all you need is the names of the galaxy and their shape. That's it. This is a picture of them. An elliptical, you can see from here, is sort of football shaped. A spiral spirals outward counterclockwise. Or is that clockwise? That's clockwise. And the regular galaxy is irregular. It really has no shape. Okay, the Milky Way galaxy. The center of our galaxy has a high concentration of stars, and our solar system is located in the arm of Orion. It's actually all the way over here in this area. And you need what is in yellow, please. Here are some parts of the Milky Way. If you could draw a picture and label the one here on the right, the side view of our galaxy, this is the one you'll be tested on. Okay, here are the parts. And if you labeled them on the actual picture from the slide before, right here, you can go ahead and just write some notes around it if you want, or you can handwrite it, either one. You still need what's in yellow. The galactic nucleus is the center. The halo is the spherical area around the star masses. This is where the oldest stars are, and we've estimated them to be somewhere between 12 and 14 billion years old. The nuclear bulge is the bulge around the nucleus. The disk is the egg-shaped edges, and the spiral arms are the arms that spiral out. These contain the youngest stars, and you need to know that our solar system is in the arm of Orion, and it's full of young stars. Here's a side angle of it. Okay, I want you to number your paper 1 through 4, and I want you to answer these questions, please. This is what I'm going to be looking at when you come to class tomorrow. You just need the answers. You do not need to write the question. Question number 1, why don't the Milky Way galaxy's spiral arms wind up? Number 2, what contribution has the Hubble Space Telescope images made to quasar studies? And that one you have to kind of think about. Number 3, why does the sky appear uniformly dark at night between the stars? So go back to the flipped portion 1. And number 4 is going back to the flipped portion 1 also. What does the cosmic background radiation reveal about the existence of the Big Bang? Here's a video. I included the link on Edmodo for you. It is Can Galaxies Collide? Just watch it. That's all you need to do. And the last portion is on telescopes and rocketry. The telescopes, honestly, take what notes you want. I think they're really, really easy once you get past this page. Some of them are honestly common sense. Okay, optical telescopes are ones that you actually look through. These gather focused visible light using mirrors and lenses. A refracting telescope uses a lens. Kind of think of like eyeglass lenses, maybe. Hold on, please. Okay, going back, refracting telescope uses lenses. Think of like eyeglasses. The larger the lens, the greater the light gathering power, so you're able to see farther with a larger lens. A reflecting telescope is like a mirror. It literally uses mirrors to collect light, and reflecting telescopes can see objects billions of light years away. Multiple mirror telescopes. There are multiple mirrors that make them up. That's all you need. The Keck telescope is the most powerful on the Earth's surface. Not in space, it is actually on the surface. All you need is what's in yellow with that. It's made of 36 mirror segments joined together to make a 400-inch mirror, and it looks like a beehive. A radio telescope collects radio waves. Infrared telescope, if you remember from 6th grade at the electromagnetic spectrum, infrared is invisible heat. So the infrared collects or detects invisible heat. Ultraviolet telescope detects invisible UV or ultraviolet rays. The X-ray telescope collects X-rays, and these provide information on the life cycle of stars. That one you need to know also. And then the Hubble telescope, it is actually in space, and it houses several types of telescopes, and it takes images of objects and puts all of these different types of telescope images together to give you a really detailed image. Okay, rocketry. I don't know why you need to know this, but you do. Um, Clearly a rocket leaves Earth and goes up into space. You need to know the word escape velocity. Velocity, if you'll remember, is speed in a given direction. So escape velocity is a velocity needed to escape Earth's atmosphere, or the amount of speed traveling upward, depending on where you are on the Earth. The cardinal direction may change, but it's the speed that you need to travel upward in order to escape our atmosphere. And the last one is deep space probes. These are literally probes that are off into space. We'll talk about more of them later, specific ones. But these are put into space to explore beyond our solar system. And I believe 2 of them have actually left our solar system, and we're still getting some information back from them. And that is it, folks. Bring those 4 questions to class. That is what I am specifically looking for. Bye-bye.